having something that can instantly pull up links to and references from global regulations is incredibly useful and an incredibly handy tool. It just makes a lot of the time consuming work happen a lot faster. Digital transformation is an interesting choice of words because it's very reminiscent of what the discussion was oriented around when kind of the first round of Internet of Things, digitally connected devices and sensors kind of came into the scene. And it's been interesting to hear how people are discussing and looking forwards to the application of AI in a number of the conferences and trade show events I've attended over the last year. And it's interesting, and I think there's a number of important distinctions. So what we saw with kind of the first Internet of Things boom was you suddenly had the ability to connect a multitude of disparate sensors, readouts, displays, machines, factories even, into a single data feed. Where we struggled, I think, after the initial boom of integration was being able to effectively use that stream of information and being effective in scaling and connecting a lot of those devices and systems. We had to create new languages for systems to talk to each other. We had to find new ways to process and analyze very large batches of data. And I think the technology and implementations at the time kind of struggled to manage that scope. So I think we didn't see quite the digital transformation or the digital revolution that in some senses we were promised from the kind of Internet of Things development. Yeah, these are the most dangerous words in the English language, but this time feels different. What we've seen with kind of the implementation of AI and automation is suddenly the ability to process and manage that very large collections of data efficiently, effectively, and quickly produce meaningful trends, analyses, and other quantifiable evaluations of that data. We're also able to connect disparate systems much more effectively and quickly. And we've seen this on the automation side of things as well. They've been able to bring automation to a broader swaths of processes and applications than we've ever been able to think about in the past. And what this has done is allowed very rapid scaling up processes and systems, and also the ability to remove people from harm's way. One example there is when liquids are transported for bioproduction reasons, you need to move blood from one site to another, plasma from one site to another. Often it'll be moved frozen in a bottle. When it arrives to where it's going to be processed, the bottle needs to be cut, generally by a blade or a saw. So then the bottle can then be tipped out and the frozen liquid released and allowed to drain and move into process. Cutting anything all day, every day is an inherently dangerous process. And when you have people who are there cutting frozen bottles, even with the safest processes, you're still going to have injuries. You're still going to have risk. And you're also limited in how quickly you can move and how fast you can scale. It's just not feasible to expect a person to be able to, get their bottle cutting time from 10 seconds a bottle to 5 seconds a bottle to 1 second a bottle. At some point, you hit an upper limit. What automation has allowed us to do is remove the person from that more dangerous position and be able to go from a bottle every 10 seconds to 5 seconds to 1 second. And now you're doing 10 bottles every second. So it's really allowed kind of a scaling and growth and removal of risk that's been true in the past as automation has come in, but we haven't seen as much in this space before. Historically, this has been a very people-driven space, very manual labor-driven space. And we're seeing that kind of across the board. So, whereas before you might have humans pipetting or moving reagents or test samples from one tube to another, now we're able to do that on an automatic basis, doing hundreds or thousands of samples at the same time. And that really enables kind of a scaling of all of these processes. And that hadn't been feasible in the last 10 years. So that's been really exciting to watch and hear about what's planned in development for that. And I think the use of AI is kind of in a similar stage right now. So AI can mean a lot of things to a lot of different people. I'm mainly focusing on kind of the applications of large language models and some agentic behavior, but really that's in its infancy. And as we'll kind of look at, there are some issues around trust and verification, validation when you start moving decision making or real oversight kind of out of people's hands. So one area where we've kind of seen kind of the rapid and successful application of AI in this space is in quality control and monitor. With the ability from the Internet of Things to have a large number of sensors providing a constant data stream on all aspects of your facility, your systems, your processes, paired with large language model AI, you're now able to, in real time and constantly, pattern check against that data stream. And with the right training information, the right training models, you're able to identify issues before they arise. You're able to identify issues earlier on in the chain. And you can direct people's attention, focus, energy, and resources at core identified problems to be resolving those in advance rather than using those same resources to both identify the problems and then resolve them. So that's been exciting to see rolled out, and I think has very scalable applications. Another application we've seen using these sorts of AI models is in using them as a backstop for preventive maintenance, expected failure states, and other kind of maintenance pieces. If you feed an AI model all of your operation manuals, all of your preventive maintenance schedules, your spare parts, the expected life on different parts, the warranties of different parts, it can then provide you a, hey, it's time to go take a look at this. It's likely this system might be failing or need to be replaced shortly. And it can act as kind of a maintenance backstop to enable one, standardization across different sites, but two, just an extra layer of oversight to ensure that critical systems aren't allowed to go into unexpected failure states. And as your production sites and facilities and labs both scale and become faster operating and faster moving with the addition of automation and other AI components, having that ability to manage the maintenance and kind of backstop oversight of the operation of those systems becomes increasingly important. I use the word backstop there intentionally because what we're also seeing is the emergence of a friction. And we're seeing this too in kind of everyday applications of AI and how people use the different models in their day-to-day life. But in the biospace, much of it is regulated and much of it requires constant validation signed off on by a person. So a person looks at the operating parameters for a effluent decontamination cycle, looks at the run data after the cycle and signs off that, yes, everything was processed in accordance with the regulations and what we said we would do. Now, various aspects of that are automated, but at the end of the day, analyzing the reporting and sending your analysis of that report onto the regulatory body always has a person driving that process. As AI is integrated more into the maintenance and oversight of these systems, where do we need the person in that step? What needs to be personally viewed and signed off on, and what can you look at and say, hey, our model told me everything ran great, so everything ran great, here are our reports. So we're seeing this in particularly where there are aspects of patients or patient care, the questions here become more urgent. And to some extent, that's been slowing the implementation or adoption of AI into this space. And for good reason. Until we have a societal agreement on what the trustworthiness of the systems is or what the liability is in the case of a system failure, that's just a level of organizational risk that is really tough to swallow right now. And in some cases may not be legal. So we're seeing the very rapid implementation of AI in some areas of the space and kind of a slower rollout of that same technology in other areas where it's being managed alongside kind of human oversight or human management. Even a lot of the organizations or individuals who might have been historically more change averse or hesitant to adopt new technologies are all seeing the immediate and future usefulness of AI. I think where there's a disconnect now is you have, call it a handful of commercially available or publicly available models that can do a whole lot of things well, but maybe not your specific thing great or perfectly. But to move to kind of the next level of integration, you're really looking at building your own LLM, using your own training data and own weighting. And there are a few different ways you can do that. But unless you have a AI capable computer scientist on your staff, that's very challenging to do in house. And that's something you're either you're looking at going to some outside group to help you build that model, to help you ingest the right training data, identify the right training data, and then sit there and play with different weightings within that data until you're getting kind of useful, actionable information and output. That's tough to do right now. There aren't a ton of people with that capability, and there's an even smaller overlap of people with that capability and with industry specific knowledge. So for a group who's not currently using or integrating AI to go out and bring that in, they either have to find someone perfect to bridge that gap, have to spend additional time and resources training someone in their segment of industry or whatever it is they do to be able to effectively build that model for them, go to a group that does this commercially but might be extremely expensive, or wait. And it's likely, I mean, with the rate things are progressing, more of that automation, more of that industry or job specific model training and weighting will be able to be outsourced or kind of done with, in a similar way to vibe coding, vibe training. But right now, that's not feasible. It's, I think a lot of groups are looking and saying, oh, that's great. I'll use it on a personal level. I'll encourage my staff or my employees to use it on a personal level to augment what they're doing now. But to integrate it at the enterprise level is just too much of a lift, too challenging. And I'm going to wait a little bit until there's less friction. So for our day to day right now, I'd say the biggest application is as a research and reference tool. So we operate in a lot of jurisdictions across the US, across the world. Having something that can instantly pull up links to and references from global regulations is incredibly useful and an incredibly handy tool. It just makes a lot of the time consuming work happen a lot faster. We've been slower to integrate it with our technologies because we're not as much integrating it just with our technologies as we are with our customers' technologies, our customers' platforms, and our customers' reporting. So anything we do would have to tie back to them. And there are, a number of considerations we have to look at around use of the data, particularly if it's in a restricted or biosecurity setting, and what we're doing with that data and what we're using it for. So I'd say right now we're looking at how we might integrate that into our systems, into our operations. In the future, might be able to let our client systems integrate back with that. But right now, it's not something that we've been actively using or aligning with our equipment and our system. I think it's certainly going to be an impactful technology in the space. And there's a lot of excitement right now and a lot of anticipation around a bioengineering, synthetic biology boom. In part, around a synthetic technology boom, in part driven by advances such as Google's protein folding model. That alone is viewed as likely to kickstart, a number of companies, if not new industries, all of whom will have significant lab, reagent, and supply chain requirements for whatever it is that they're now able to do through that technology. So I think everyone in the industry is uncertain as to where it's going, but they're all very excited. We're all very excited about the potential.